Okay class, so like we did in the intro part, okay, so in this acid-base titration, the neutralization reactions involved are, so this is the part A, where we are going to titrate oxalic acid with sodium hydroxide, okay, and acid plus base, okay, produces salt and water. Okay, so look at the acid. This acid is diprotic, so please make sure you balance the equation well, right? So please be careful. So when it is diprotic, the ratio of acid to base is 1 to 2, right? Not 1 to 1. So it's very important because we are going to calculate the concentration of sodium hydroxide from the concentration of our acid. Right, so if the stoichiometry is incorrect, so that's mean you are going to write that's mean you are going to get the wrong concentration of our base. As for sorry, not part A, this is part B. Okay, experiment part B and experiment part C, you are going to titrate another acid, which is HCl acid, with the same base, okay, NaOH, going to produce salt and water. So these are the two equations for our neutralization. So here is the apparatus, okay, burette, glass rod, white tile, okay, you need to use for neutralization, use small white tile, okay, retort stem, filter funnel, 50 ml beaker, 25 ml pipette, okay, analytical balance, okay, it can measure up to 4 decimal places, 250 ml conical flask, 250 ml volumetric flask, and 50 ml measuring cylinder. Meanwhile, for chemical reagent, we will need X molar, that's mean unknown concentration of HCl, 0.2 molar NaOH, distilled water, phenolphthalein as an indicator, and also hydrated oxalic acid. So let's have a look at the procedure. For part A, preparation of standard solution. So first thing first, you need to weigh to the nearest 0.0001 gram, about 3 gram of hydrated oxalic acid in a 50 ml beaker. So that means you must get a 50 ml beaker and then put it on the weighing scale. Okay, so the weighing are going to show the mass of this beaker. Then you need to tare. Tare means the reading will be back to 0.0000. So after get the 0 reading, you can add about way to the nearest. That means plus minus 0.0001. You must be very accurate. So it could be 2.9999 or exactly 3. That's very good. Or 3.0001 gram. Other than this value, cannot proceed. That means you must try to get between these three values. Okay, because we need to weigh accurate. We need to produce an accurate concentration. Next, okay, that means you have to weigh inside the beaker, not first weigh in the filter paper and then transfer. No. Okay, that means you have to weigh that 50 ml beaker first, and then tare the reading becomes 0, and then you add in your hydrated oxalic acid powder. Okay, next, add approximately 30 ml. So that at this time, okay, you measure this distilled water, not tap water, okay, distilled water, to dissolve the oxalic acid. Next, so now you can use the glass rod. Okay, kacau sampailah dia dissolve, larut. Okay, and then transfer the solution into a 250 ml volumetric flask. Okay, so this is what volumetric flask look like. Okay, so in order to transfer into this volumetric flask, please use a filter funnel. Okay, next, after you have transferred this 30 ml dissolved oxalic acid, it will just be here, but you need to add the volume up to the graduated level. Okay, so that means there are still you need to fill this with distilled water, but then please don't jangan bazirkan oxalic acid kita tadi yang berada dalam beaker. So beaker tadi, okay, beaker tadi kan ada glass rod. Okay, once you dah transfer, you buat apa? Kita kena rinse dengan distilled water. Rinsekan dia. Rinse dengan distilled water. And then pour inside this volumetric flask, because we want to make sure as much as oxalic acid will be transferred into this volumetric flask. Okay, and then rinse this filter funnel, let's say up till this. So this is all filled with solution. So we still have very small volume to reach the graduated level. So at this point, you must be very careful, right? Why? Because we don't want you to add more than this graduated level. Okay, let's say how to look at the graduated level. So this is the graduated level. That means if you fill up solution up to this, that's mean you you have 250 ml solution if you fill up to this. But then how? So please make sure this graduated level is parallel to the bottom of the meniscus. Bottom, bawah. So this is the correct way of taking the reading. Make sure your eye level of the observer is perpendicular, right, to the graduated level. If you measure it like this, it's very wrong. You said, Madam, average graduated level. No, not the top of the meniscus, but make sure the bottom of the meniscus is in line with the graduated level. So how are we going to make sure that it is very accurate? So remember this, at this section is very tiny, long and tiny. So that means you must be very careful. So when you keep adding distilled water, okay, make sure you don't jangan lebih discredited level. So bila nak sampai dekat-dekat nanti, okay, ambil beaker yang bersih, okay, isi distilled water, okay, isi distilled water, kemudian guna dropper. Remove with the funnel, kemudian isi drop by drop. Sampailah dapat seperti ini. Madam, kalau terlebih buat balik. Itu sahaja solutionnya. Saya pernah terlebih, lepas tu dia sedut balik, buang. Okay, you boleh tipu diri sendiri, tapi nanti result part B tak sama sebab you kira molarity, you kata volume dia 250, tapi sebenarnya volume yang you dapat kalau you terlebih itu bukan 250. Contoh dia macam ini. Ini graduated level. Atas lebih. Tak boleh. Nanti dalam part kertas you buat macam ni memang kena ulang balik. Repeat. So sebab tu saya kata you must be very careful. Memang dia tak cakap dah ni, ambil pipette lah, ambil dropper semua, tapi macam mana kita nak ni add distilled water up to the calibrated mark. So you must know this. Ini step ni penting. So you kena tahulah kemahiran ini. Okay, so jangan cakap saya tak bagi tahu. Bila sampai nak dekat, remove filter funnel, isi drop by drop. So bila you dah dapat macam ini, okay, panggil saya dulu, Madam betul tak macam ini? Sebab walaupun saya duk cakap jangan macam ini, ada juga yang dia ingat sampai sini dah sampai dah graduated level, tak sampai gini. Okay, so now lepas you dah dapat macam ini, stopper and shake to obtain the homogeneous solution. Okay, kemudian calculate the concentration. Okay, so next standardization. Okay, so kita akan buat, lepas sudah dapat standard solution ni dah siap. Okay, kemudian kita nak buat titration lah. Okay, so standardization of 0.2 molar NaOH solution, rinse a burette with a given NaOH solution to be standardized. Okay, ingat burette dengan pipette sebelum kita guna. Actually sebelum apa-apa benda guna, you kena rinse dengan distilled water dulu sebab kita tak tahu yang kita dapat tu bersih atau tidak. Kadang-kadang tu orang tinggalkan benda tu, kita tak nampak solution tu colourless, kadang dia guna acid dia tak basuh. Jadi bila kita tambah apa-apa indikator ke apa, dia akan berubah warna. Jadi kita tak maulah benda tu. Okay, kita nak a clean chemical apparatus. Jadi you kena rinse distilled water dulu. Walaupun not mention here, tapi you kena tahu bila guna burette kena rinse 2 kali. Okay, yang pertama rinse dengan distilled water. Distilled, not tap water, distilled water. Yang kedua kena rinse dengan burette ni kita letak titran kan. So titran apa? Let's say dia kata titran kita NaOH, jadi kita kena rinse dengan NaOH lah. Okay, kemudian fill the burette with the NaOH solution. So fill ni you tak boleh pegang pakai tangan, of course kena clamp dengan retort stand. Okay, ensure there are no air bubbles trapped at the tip. Okay, actually tambah kita punya burette ni, Okay, macam tu. So, tak nampak dengan jelas. Padam sedikit besar. Tip ni. Okay. Selalunya, okay, kat sini ada tab lah untuk you buka tutup. So, selalunya you kena perhatikan ada tak air bubble. Sebab apa? Sebab air bubble ni, dia affect the accuracy of the reading. Okay, because we know burette is accurate where it can measure up to 2 decimal places. Okay, jadi you must make sure there are no air bubble. Sebab kalau ada air bubble, maksud dia reading kita ni bukan seperti yang kita baca di sini. Maksud dia ini ruang ini diisi oleh udara, bukannya diisi dengan solution. Jadi you kena remove air bubble. Macam mana nak remove? Okay, you kena open this tab, buka dengan luas. Okay, sebab tab ni kita boleh control untuk flow dia jadi laju ataupun jadi slow. Macam macam pipe air kan. Macam itulah kita boleh buka tutup. Jadi you kena buka dia semaksimum mungkin. So konsep dia, solution ini bila you buka lubang dia besar, jadi dia boleh push this air bubble down. So bila air bubble ni keluar, jadi solution ini akan terisi dengan solution kita lah part ini. Bukannya air bubble. Kemudian tutuplah balik. Tutup balik, record reading. Okay, baru record reading. Berapa? Okay, record to 2 decimal places. Okay, sekarang ni bila record to 2 decimal places, okay, awak baca reading So kata kat sini 3. So reading awak 3.00. Okay, ada manusia yang suka tolak. Dia kata satu ni 50. So 50 tolak 3. So initial reading dia 47. No, bacaan means you tengok kat sini. Nanti lepas habis kita titrate, let's say it stop here, barulah kita letak final reading dia berapa. Contoh final reading dia 25.5. Jadi volume yang kita guna 25.5 tolak 3. Dapatlah 22.50. That's the volume that we use. But when the procedure asks you to record the initial burette reading, that's me reading, bacaan. After you finish removing the air bubble, please record. Okay, record in the table. Okay, table dia macam ni lah. Table dia macam ni. Record initial reading. Kemudian habis final reading.